As I mentioned earlier, the Dawn mission saw its final days of the mission not too long ago. We're going to hear about that. But in honor to welcome our guest, Dr. Marc Rayman from Jet Propulsion Lab, we created just a very brief tribute video to the mission. So with that, can we have the lights up? And please welcome Dr. Marc Rayman.
Thank you.
We had fun making it.
I had fun making it too.
Yeah.
I'm looking forward to my residuals checks.
Yeah. Okay. We'll start right with this image because, as I mentioned, this mission, well, I didn't mention, but it was a little over 10 years long, and it had a very interesting journey.
It did.
Yeah, can you tell us a little bit about it?
Sure. In fact, it was unique. This is the only spacecraft ever to orbit 2 extraterrestrial destinations. So as you can see in the picture here, we departed from Earth in September 2007 and gradually spiraled farther away from the Sun, flew by Mars in February of 2009 in order to steal some of its orbital energy around the Sun in order to help fling the spacecraft farther away. And JPL, being very responsible, we believe in conservation of energy. And so to speed the spacecraft up, we actually had to slow Mars down. And so if you're keeping track, Mars goes around the Sun more slowly now than it did before Dawn flew by. We decreased its velocity by 1 inch per 180 million years. Then in 2011, we got to Vesta, which is the second largest object in the main asteroid belt. Went into orbit around it, spent 14 months there, making a comprehensive set of measurements. And then in September of 2012, broke out of orbit, traveled for another 2.5 years and 900 million miles to get to Ceres, went into orbit around Ceres, where the spacecraft is now and will be essentially forever. And stayed there a long time as we continued to take data, and we could even zoom in and see where the spacecraft is today. You can see this is just a few weeks after the mission concluded, as you heard a short time ago, and Ceres is right there. We can also zoom in and see where Vesta is now, and I think it's pretty cool because Dawn is now much farther away from Vesta than the Earth is from the Sun. I mean, to me, this is truly an interplanetary spaceship to be able to go these fantastic distances and orbit these different bodies. And as long as we're zooming in, we can zoom in and see where Earth is today. And actually, what do you know? That's where we are today. And I can see somebody there. I think it's that person over there may have left their headlights on. But anyway, so that was the mission. See, there's an animation here. You know, when you look at a picture like this, it's flat and it's static. And it's easy to lose track of how complicated this is. So we can watch an animation of this because, to me, the solar system has this big, complex, beautiful choreography. So if you will track this, we're starting showing where things were in March of 2007. And if you follow along, you'll see Earth is the inner orbit, blue, Mars for red, then Vesta, then Ceres. And in order to catch up with these bodies, you have to actually get there when they're at the right place. And so now let's watch as the spacecraft departs from Earth, firing its engine, aiming for Mars, but Vesta's going to go all the way around once and Ceres almost twice before Dawn could get there. But we fly by Mars, then we're aiming for Vesta, but we're not going to get to it until near the bottom of the screen there. But finally, sure enough, in the summer of 2012, we get into orbit, spend our 14 months there getting the data, then break out of orbit in September of 2012. And it looks like we're right near Ceres, but it is a long, arduous climb through the main asteroid belt to get from Vesta to Ceres. But to my never-ending gratification, every time I watch this video, we always eventually get to Ceres. And it went into orbit, and that's where it is now. And I think this sort of illustrates what you were just talking about. How can we do a mission like this? In more than 60 years of space exploration, no spacecraft prior to Dawn had ever tried to orbit 2 extraterrestrial destinations. And that's because of our unique ion propulsion system. And I'm sure you recognize the TIE fighter that Darth Vader and the evil Empire used against Luke Skywalker, look-alike for Marc Rayman that we just saw in that video. And in the Star Wars universe, the TIE fighter, TIE, stands for Twin Ion Engine, because this was the most futuristic, coolest, advanced technology that George Lucas could think of. And to me, one of the things that's so cool about working on a project like this is getting to turn that science fiction into science fact. And here's an artist concept of Dawn using its advanced ion engine to fly into orbit around Ceres. And the reason this is so valuable, so powerful, is because ion propulsion has 10 times the capability of conventional chemical propulsion. So this would be like having your car get 300 miles per gallon. And that's what allows us to undertake a uniquely ambitious mission. And you can see in this picture, it really does produce the cool blue glow like in science fiction movies. That's because we use the propellant xenon, which is like helium or neon, but heavier. And xenon just happens to glow blue like neon just happens to glow orange.
And how does it work? Do you burn it the way you burn fuel?
Yeah, well, so that reminds us the way normally you do it is you push a propellant out of a rocket engine by burning it, and the action of the propellant going out causes a reaction that pushes the engine in the other direction. But instead, we use electricity. So we give the xenon atoms a little electric charge, and then they're called ions, and we can accelerate them with a voltage. So we use about almost 1,300 volts with 2 grids separated by only 10 times the thickness of your hair, and that accelerates these ions up to 90,000 miles per hour. And because they depart with such high velocity, they give a large push back on the spacecraft. And that has allowed Dawn to change its velocity by far more than any spacecraft ever has. But the other side of this is the thrust is very gentle. We only flow a very small amount of propellant through the engine at a time. And so while it's efficient, it's weak. And so I think it's safe here. I'm going to do an ion propulsion experiment. And that is the ion engine pushes on the spacecraft as hard as this piece of paper, that's fine, as this piece of paper pushes on my hand. But in the zero gravity, frictionless conditions of space, gradually the effect of this thrust can build up. And so it would take Dawn 4 days to accelerate from 0 to 60 miles per hour. It doesn't exactly evoke the concept of a drag racer, but instead of thrusting for 4 days, if you thrust for a week, or a month, or a year, or as Dawn ultimately did for almost 6 years, you can achieve fantastically high velocity. And so this is what I like to call acceleration with patience. And if you're patient, and I am, I'm a very patient guy, this is a great way to explore the solar system. And this is really the key to what allowed us to undertake this mission.
When's the next ion engine going to launch? The next one?
The question was, when is the next ion engine, next interplanetary mission to use ion propulsion going to launch? In 2023, it's a mission called Psyche, P-S-Y-C-H-E, which is going to an asteroid called Psyche, which is believed to be the metallic core of a protoplanet that broke up early in the solar system history. And there's a destination, another one like Dawn's destinations, that would not be possible to reach without ion propulsion. So it's a cool mission. Come back to All Space Considered in 2023 and they'll tell you about it.
So
So yeah,
that's right. Yeah, it'll be valid that year. Yeah.
So tell us a little bit more about the objects that you visited and why you went and what did we hope to learn and what did we learn?
Yeah, so we went to Vesta and Ceres, the two largest objects in the main asteroid belt. And I think when most people think of asteroids, they think of, sort of chunks of rock the size of buildings or mountains. But these are not that way. And in fact, this shows all of the asteroids that have been visited, that a spacecraft have visited, including in that little square in the bottom, Braille, Ryugu, Bennu, and Itokawa. And there are spacecraft right now studying Ryugu and Bennu. You'll just have to take my word for it that there are really pictures of those bodies in that square. They're pretty small. But you can see Vesta on that scale and Ceres to the same scale. These are very different bodies. And in fact, Ceres, well, get to that in a moment. These are really different. In fact, there are millions, truly millions of objects in the main asteroid belt, and yet 45% of that mass is contained in Vesta plus Ceres. And the reason for going there is we want to learn about the formation of planets. And these are objects that were in the process of growing to become full-size planets at the dawn, get it? Yeah, the dawn of the solar system when their growth was cut off. And so that's why we want to study them. And so instead of comparing them to just these little chunks of rock, we can give a different context. Here they are again, Vesta, 350 miles in diameter, Ceres almost 600 miles in diameter. Here are the largest asteroids that spacecraft had visited. And Matilda I have there because it's the largest one a United States spacecraft had visited. And in the interest of full disclosure, I should tell you I exaggerated its size because I made it a pixel so that you could see it. So you can compare it to other objects that you're more familiar with, and you can see this is much more like other bodies, including Pluto. And Ceres was discovered 129 years before Pluto. It is the first dwarf planet. I'm sure you remember when Pluto was demoted. How could Earth be such an interplanetary bully? This was so awful. Why were we so inconsiderate? Why didn't we think about Pluto's feelings in this? Well, at the time that category of objects, dwarf planets, was created, Ceres was the first known object to fit in it. So they're neat places.
So do we need to feel sorry for Ceres too?
I think we should feel happy that we're getting to explore these bodies. And Ceres used to be known as a planet. In fact, you didn't ask how many people came to All Space Considered 200 years ago. But for those people who were here, you would have learned in school that Ceres was a planet. That's how it used to be known. But anyway, so this is Vesta as viewed by the Hubble Space Telescope before dawn got there. This is the best view we had. And this is what we saw from dawn. And you see that triplet of craters just a little left of center. That's what we call the snowman. In fact, you can see it here on my necktie. And we took 30,000 pictures of Vesta, and I asked for time to show each and every one of them, but considerate though my hosts here were, they didn't give me enough time, but I've got an animation here to show you what Ceres would look like if you were lucky enough to be there. And one of the things you'll notice is that the northern hemisphere is much more densely cratered than the southern hemisphere. And the reason for that is there was a giant impact about 1 billion years ago deep in the southern hemisphere that sprayed out a bunch of material, much of which landed back on the ground and wiped the surface clean. It also excavated those canyons you see near the equator there.
You mean those grooves?
Those grooves. Those actually rival the Grand Canyon in size. And I shouldn't say it excavated them. It imparted so much energy to Ceres that it reverberated inside and the ground broke up. And now we're looking at the South Pole in a crater 300 miles in diameter with a mountain 110 miles across at the base with a summit that rises to 2.5 times the height of Mount Everest. This is the second tallest mountain known in the solar system. Olympus Mons on Mars is a little taller, but not much.
And how about compared to the diameter of the body? I mean, it's
90% of the equatorial diameter.
So that would be like on Earth if we had something that was about the diameter of Earth jutting up.
That's right. Yeah.
It's a mountain.
It's amazing.
Wow.
And in fact, when that impact occurred, it sprayed a lot of this material back onto the surface of Vesta, recovered it, but it also sent a lot of that material out into space. And some of it made its way to Earth. And we now know, thanks to Dawn, that about 6%, I mean, think of this, 1 in every 16 meteorites seen to fall to Earth came from that one impact at Vesta. We have more meteorites on Earth than we do, from Vesta that is, than we do from the Moon or Mars. In fact, we even have more material in laboratories on Earth from Vesta than we have from the Moon, accounting for the 840 pounds of material that astronauts brought back.
Wow.
And one of those rocks landed in this box. And they're so common, these are not expensive. You can easily buy meteorites from Vesta. And I just bought this myself even before I became involved in the Dawn mission, because I thought it'd be cool to have a meteorite. Never occurred to me at the time I would actually get to send a spacecraft to that destination.
And how long ago was that impact?
About 1 billion years,
Wow.
but you could check one of these calendars to get the exact date. So that's a quick overview of Vesta, a neat place. And then we went on to Ceres, and here's a view of that dwarf planet. And you can see it has a lot of craters. You may see down near the bottom some long straight features, some streaks, but especially a lot of these bright features like the one coming into view there, including this crater. And this to me was one of just the coolest things to see. And when we first saw this, a lot of people said, oh, could this be lights of an alien city? And I'm glad you laughed, because I find questions like that disturbing. I mean, it really, seriously, it calls into question people's critical thinking. That we're taking the best of human science and technology, sending a spacecraft to a distant alien world, just approaching it, and people are wondering if this is lights of an alien city. I mean, it just has to make you wonder. You know, how could we know if the Syrians even live in cities? You know, maybe they live underground. Maybe they live in rural communities. There's no way we can know they're in cities. It just shows people don't think critically. But anyway, so this crater here called Akator is 57 miles in diameter, and I think these features are really just mesmerizing. It's like they're casting their light like a beacon out into the cosmos. And I'm going to show you some close-ups of what we saw here just in our recent orbit. So just in the last few months, that area there, we now see to be this. And what we're seeing is, it turns out Ceres has a substantial inventory of water underground. Most of it frozen, and it's salt water. And so some of that salt water made its way to the surface. You can see quite a large number of fractures in the ground there. So that perhaps provided a conduit for the water to make its way to the surface. In the cold vacuum of Ceres, the water would freeze and then sublimate, that is, go from being a solid to a gas. Water molecules dissipate. And the salts that were dissolved in the water were left behind, and they're very reflective. And so we're seeing salt flats there. And if you look in the lower left, this structure here, I will show you still another close-up picture of that in a few minutes. But I want to show you this area as well. Close up. Really intriguing. You can see it's got these large fractures cutting through it, which again may have provided a conduit. And there's some evidence that the material didn't just seep onto the surface, but arrived explosively or eruptively. That is, it shot out, sprayed out, perhaps traveling hundreds of yards into or above the ground, excuse me, before being deposited.
So Okator is the freshest, the youngest of these?
It is. And we estimate it to be about 20 million years old. Excuse me, which in geological time is very young.
Yeah.
But it's interesting that this bright material is estimated to be much younger than that, perhaps only something like 4 million years, which indicates Ceres is still active. This is a geologically active world. It's not just a passive, dead, inert place. And I'll have a little more to say about that in a moment.
It's the underground factories.
That's right, yeah. That's right. They have to manufacture their light somewhere.
Yeah.
So now, here's a perspective view, and you can see, again, those same bright areas. And now we can zoom in a little bit. And you can see the central one that's now a little bit on the left is actually in a pit. There's a dome there. But just in the last few months before the mission ended, we were getting very high resolution pictures. In fact, we flew Dawn down. This is a dwarf planet that's almost 600 miles across, and yet we flew the spacecraft down to only 22 miles above the ground. So that's only 3 times higher than you are if you fly across country in a commercial aircraft. That would be like if you had a soccer ball getting to within 1/3 of an inch of the ground. And so, show you a zoom in of this place on the crater wall here. And I just think it's really cool to see these complex structures, material that eventually perhaps will collapse. But you can see these are big features. I mean, you know, significant fraction of a mile across sticking out of the crater wall. And here again in this diffuse area, look at this. It's funny, this square feature, why it has such a rigid-looking structure like that is not known. But the fact that it's associated with this long fracture must say something about how it came into being. But these data are so new that it's too soon to reach any conclusions. In fact, the way I like to think about it is the big question now is, would you describe these pictures as amazing or fabulous? Those are the kind of questions I feel like those are the only things we can answer right now.
And the answer is both.
I think that's exactly right, yeah. And we can zoom in even more, and you can really see now these mountains right around this pit are several thousand feet high, and the dome in the middle of the pit is itself about 1,000 feet from the base of the pit. Now we can flip around and look at it from the other side, and this sort of funny-looking structure here that I showed you earlier, here it is. That white, somehow there was a glitch in transferring the picture, but those black features there actually are saturated white. And you can see this is sort of like, it's almost like a mesa here, this thing, flat top. And look at these flows here. So clearly material is able to flow under the influence of gravity on the surface there. And zoom out and take a look at just another the features there. And you can just see how sharp the boundary is between this bright and dark material. Very intriguing. Looks to me like a nice place to take a hike. And there's the crater again. And we can zoom back out and see just this mesmerizing area. And one of the reasons I included this picture is we knew the mission was coming to an end, and so just a couple of months ago we decided to take some sort of farewell pictures of Ceres, and this is one of them, just looking back at that mesmerizingly beautiful crater. And this is another of our farewell pictures, and I think it's really cool that you can see on the limb here this, well, I guess I can't quite see it from here, but you can see near the top a structure extending up above the limb. Yeah, this thing right here, which turns out to be a cryovolcano. A volcano on Ceres, everything is cold there, so we call it a cryovolcano. And
Not because it's crying, but because
that's
it's
right. It's cryogenic.
cryogenic.
Right. And this
Icy.
is a synthesized view of it from within a nearby crater. This is what it would look like if you were looking over the rim of this crater. The crater is about 11 miles across. Coincidentally, and it is coincidental, this volcano, Ahuna Mons, is about 11 miles across at the base and about 13,000 feet high. So this is a big structure. And it's kind of cool. From the deepest point in this crater to the top of the volcano is about 25,000 feet vertically, but only 9 miles horizontally. And in the Ceres has gravity just a little over a 40th of Earth's. So, you know, you would weigh 3 or 4 pounds on Ceres. So I think that would actually make a nice day hike. You could ascend that 25,000 feet as long as your spacesuit wasn't too awkward to travel in.
I'm thinking more about skiing down it. I think that seems like a lot of fun.
Well, but to do that, first you'd have to hike to the top. I guess it depends on where you land.
Right.
But anyway, so I think this is really a cool structure. And this volcano is relatively young. It formed in recent geological time. Sometime, the age is pretty uncertain, but sometime between maybe 70 and 200 or 240 million years ago. Here's another view of it. You can see it just rises steeply from the terrain there.
What causes it? I mean, the word volcano suggests that the ice from underneath is maybe liquid, the water, and then it rises up.
That's exactly
right. Is it like a volcano on Earth, or is it different?
It's like a volcano on Earth in that there's a magma. We call it cryomagma. On Earth, it's a silicate-based rock. It's rock. On Ceres, it's a mixture of mud and salt and water. I mean, rock and dirt, and that erupts onto the surface. And over a time scale, it's difficult to estimate, but a few hundred to a few 100,000 years is how long it took to build this 13,000-foot mountain. So it wasn't in minutes, but still a relatively short time.
And what causes it to?
That's a subject of much debate because Ceres, I mean, like Earth, our internal heat comes from radioactive materials which decay and provide the heat. That would be the case on Ceres as well, but it's small enough that there's good reason to have believed that it would have lost its heat over the lifetime of the solar system. But now that we know better what its composition is, turns out that it has some good insulators in it, and so it may have held on to its heat longer than we otherwise would have thought. And the fact that this eruption occurred again in recent geological time indicates that there still is internal heat. Maybe it was activated by an impact from an asteroid that excavated a crater, or maybe it was still just leftover heat. But it's recent enough to suggest that there may still be melted material inside Ceres even today.
Is there a magnetic field?
We don't know. We don't have a magnetometer. For those of you who couldn't hear, the question was whether there's a magnetic field. But we've just recently determined that, so for the first few years, literally the first 3 years, Dawn got to Ceres in 2015, we thought this was the only cryovolcano. But just literally in recent months, geologists have detected more. And they now have more than 20 likely cryovolcanoes plotted in the picture there. And Ahuna Mons, the one we were just looking at, is in the top right there. And below it is another one which is much harder to see. So you can see I've highlighted it there. And the reason they're so hard to detect is because they're made of so much ice. And so over time, the ice relaxes. Just like if you sort of pinch your skin and let go of it, it gradually returns to its original shape. And on Ceres, that happens on timescale short enough that volcanoes that formed a few 100 million years ago are already starting to disappear. So the way these have been identified is by looking for structures that have sort of the correct volume, that is about the same amount of material in them that Ahuna Mons has, but which are a little lower and broader, indicating that they're gradually flattening out. So there's been a fair amount of work to identify these, but it suggests that Ceres indeed has a volcanic history. It's not as volcanic as a place like Earth, and the amount of material that comes out is many, many thousands of times less than on Earth, even if you scale it for the size. But volcanoes contribute to shaping this dwarf planet. And I think that's pretty cool. It's a cool discovery. So there are other things going on Ceres as well. It's not just volcanically active. And this is a crater called Juling. We discovered that over a period of 6 months in 2016, the ice on the northern wall, so this at the top, so north is at the top, this is the northern wall here and up here, the area of ice grew by almost 500 acres over a period of 6 months in 2016. And the reason for that is that this crater is in the southern hemisphere, so the north wall is shadowed, so it's colder there. But as the sun moved south, that is, as it got into southern hemisphere summer, the sun heated the floor of this crater, and water that was in the crater sublimated. Again, molecules went into space and settled on that cold northern wall. We believe there's a seasonal ice cycle. The ice goes between the crater floor and the crater wall, and it goes back and forth as the seasons change. That's one of the many benefits of having a spacecraft in orbit, being able to spend time there studying it and seeing these kind of changes. But there's another change that I think actually just looks cooler, and that is this close-up picture we got of a ridge in a different crater, another crater called Urvara. And I don't know how well you can see it, but there are tracks of boulders here. And so this, for example, is the trail of a boulder that tumbled down the wall, and there's the boulder right there. And this is the trail of another boulder, and there's the boulder. And here's a trail that crosses another one, and there's the boulder at the end of it. Here's another one. You can see it got a hole in one here. And so you can see there are many trails here. There's another one. And this crater, we estimate to be 1 billion years old. But these boulder trails are very recent. So something's continuing to go on that triggers these boulders to fall. And you can see that there are more up still on the crater wall, like this one. And you can see this is a mile, so this is a long way down. It's still going to tumble at some point. Here's another one at the end of its trail. So I think it's really cool to see that this is still an active place. And frankly, I think it's cool to have been able to get close enough to see rocks at the end of the trail from tumbling down the crater wall.
What's the, what do you think caused the, like, series of potholes?
That's from the boulder bouncing down.
Okay.
Yeah, so it didn't just roll, but, you know, it maybe hits a little thing and that causes it to just bounce.
Like
Yeah.
Wesley and Buttercup rolling down a hill.
That's right, yeah.
How recent was that? You mentioned this was recent.
Yeah, we don't have an estimate yet for the age, but I don't know whether we'll be able to pin it down or not. But again, since the crater is 1 billion years old, we know it was much, much more recent than that, but not yet possible to put a number on it. Probably didn't happen this year. Yeah.
So
So
you reached the end of all of this science.
we did, and the spacecraft ran out of propellant on October 31st, Halloween. And it doesn't need propellant to stay in orbit, but it needs propellant to orient itself in the zero gravity of space. in order to point its solar rays at the sun to produce electricity, or to point its antenna at Earth, or its cameras at the ground, or its ion engine in the direction it needs to go. And we had known for a long, long time that it was about to run out of propellant. That's why we took those farewell pictures. In fact, we thought it might actually run out of propellant earlier than it did. It hung on to the end. It was good to the last drop. But the spacecraft now is just in an orbit like this, getting down every 27 hours, continues to skim just 22 miles over the ground, and then it goes up to 2,500 miles. This is the orbit we left it in, and this is the orbit that it's in now.
And how much longer will it stay like that?
Well, that's a good question. We are not allowed to let Dawn come in contact with Ceres for at least 20 years, because we know Ceres has a substantial amount of water. I mentioned that. Dawn detected organic materials on it, a rich inventory of other chemicals. We talked about it having internal heat. So it has many of the ingredients for life. That's not to say there's life there, but there's chemistry related to the chemistry that led to the development of life. And we don't want to contaminate that with our organically dirty spacecraft and terrestrial materials.
Are your germs on that spacecraft? Have you touched
Some of
it?
my personal germs are, yeah. I gave some of the best germs I have to that spacecraft. And so, oh, pardon me?
Why did you say 20 years for that?
I still can't hear.
Oh, why 20 years?
Oh, why 20 years? Yeah, it's a good question. In fact, before I tell you why 20 years, let me tell you why many people think it's 20 years, but this is not the reason. A lot of people quite reasonably think that's to allow the spacecraft to be sterilized by being in the temperature extremes and the radiation and the vacuum of space. But it's not. Over 20 years, believe me, there are still microbes that could live much longer than that. Rather, it's to allow enough time that if we wanted to conduct a mission focused on biological exploration, we would be able to do that. That is, conceive of, design, build, test, launch, fly, and operate a mission to do exploration, to follow up on our findings, and to study the astrobiological potential of Ceres. We could do that before it would be contaminated with a spacecraft that would compromise those measurements. Right? If you found organic materials there, and we know there are some, but if you found certain ones, you wouldn't be able to tell if they came from Ceres, if they were intrinsic to it, or they were a result of our contamination. And so that's why we have 20 years. But our analysis showed that even over 50 years, there is a better than 99% chance Dawn would still be in orbit. And in fact, our most recent analysis says it could quite credibly be many hundreds of years. We've taken the analysis out to more than 600 years and showed that Dawn could even still be in orbit then. And any calendar that you get here now would still have an opportunity to help you track that in the future. So the way I like to think of it is, now that we've run out of propellant, Dawn has just become this big, inert, celestial monument to human creativity and ingenuity in virtually perpetual orbit around one of the alien worlds that it uncovered.
Yes, question.
Would it be possible to walk on this Ceres, considering the weak gravitational pull?
It absolutely would. So the question was, would it be possible to walk on Ceres? The biggest challenge with walking on Ceres would be getting there. But yeah, but once you're there, I mean, again, the gravity is a little more than a 40th. So if you weigh, you know, a little more than, say, 120 pounds, you'd weigh 3 pounds. Well, a 3-pound object on Earth definitely is rooted to the ground, right? You could easily loft yourself, but you would come back down. So yeah, it'd be a great place to take a hike.
Are the solar panels useful?
Did you say, are they useful?
I mean, I know there's no propellant, but can't it spin naturally towards the sun and charge?
So the question is, if I could rephrase the question, and if this is not a fair rephrasing, tell me, could the spacecraft just sort of serendipitously point its solar arrays at the sun and still get electrical power even though it can't control its orientation. Is that a fair restatement? It can, and in fact it likely will. That is, it is slowly tumbling, and very slowly. When we ran out of propellant, it was probably moving at about 1,000th of the speed that the hour hand on a clock moves, something like that. It'll gradually spin up a little bit. So yes, it sometimes will just by luck point the solar rays at the sun. However, when it does that, the computer could wake up and say, oh, here I am. And turn back on. But before it will be able to execute all of its functions, it will then continue to rotate and lose power again as it's...
That is so sad.
It's sad, but the spacecraft will each time just quietly fade out.
Oh, for cryo out loud.
Oh, okay. Well, that was a good one. With that, we have time for maybe one or two more questions, and I know that Dr. Rayman will be happy to stay during break and answer questions. Yes?
Would there be any value to someday go back and try to retrieve the spacecraft?
The question was, would there be value to someday to retrieving the spacecraft? I think the principal value would be historical, perhaps biological, because I have some of my own germs on it still that I would be willing to take back. But I mean, it would be, again, an interesting historical artifact from primitive humankind's efforts to reach out into the cosmos, right, to extend our reach far from home. It also would be interesting, of course, to see how the materials fared, because under the assumption that this would be many, many decades, if not centuries in the future, it would be interesting to see what the effect of all that time on the space environment would be. It also, I suppose, would be an opportunity, now that I think of it, think of these big solar arrays, each one the width of a singles tennis court. We know when they left Earth that they were pristine. Now they're very large. If you studied it after a known amount of time and you measured how many little holes were in it, you could actually improve perhaps your understanding of the amount of material in space that's flying, right? Because you have a certain area, a certain amount of time, and you could measure that. So there would be things like that, and maybe for the Air and Space Museum in Washington or the extension of it on Mars or somewhere else, putting it there, I think would be nice as well.
So we contaminated the moon 50 years ago?
Yeah, we did. That's okay. So planetary protection doesn't apply to all bodies in the solar system, and there is no biological interest in the moon.
Maybe one more question. Yes?
So it looks like Ceres is one of the smallest spherical objects in the solar system. Is there a threshold beyond which a body can't stay non-spherical?
So the observation was that Ceres is nearly spherical, and it is. That's what allows it to be classified. That's one of the attributes that lets it be classified as a dwarf planet. But the subsequent part of it was, is there a threshold for a size below which objects will not be nearly spherical? Is that? And there is, but it depends on the specific composition of the body, because you can imagine things that are very rigid would need to be much bigger, so their gravity would mold them into a near sphere, whereas if it is something that flows more easily, you could think of it as being less viscous, then it could be smaller. Even much smaller objects, I mean, Vesta, which is 350 miles in diameter, is very close to being nearly spherical. It didn't look that way so much in the picture I showed you because of that big impact that excavated that crater. But when Vesta was forming 4.5 billion years ago, it was close to being able to get into a nearly spherical size. But a lot more work needs to be done to understand where really the threshold is. But Ceres is comfortably above it. I mean, it's definitely fits well into the category of dwarf planets. Did that answer your question? Okay.
So I'm going to take the last question, which is two questions. Do you
Okay.
watch The Expanse?
No, I don't watch it, but I read it. I've read the first three novels.
Okay. Oh, well, yes, I watch it on TV. So, Ceres Station, is it ever possible? Will we ever have the head of the Belters, living in Ceres Station?
Absolutely. I don't see why not. In fact, we've done the reconnaissance. They could even pick a location right now. I think they're at least in the books, they treat Ceres as just sort of another asteroid, like Eros.
Yeah.
And they de-spin it and things like that. I don't think they appreciate how big Ceres is, but it has a lot of natural resources, and so I think absolutely it could be a great place for
So there'll
Belters.
probably be the Rayman outpost on Ceres.
I'd accept that.
Yeah, I can understand that too. So let's thank Dr. Rayman once again.
Thank you.